All right, we're beginning to take a look at college algebra, and which is essentially Algebra 2 for a high school student. And the first thing we want to do is get some of the basics. Chapter 1 is going to just kind of refresh you on some things from Algebra 1 that you would need in order to be successful here. And the first thing is talking about the different types of numbers. It's a big deal. It's very basic, but the better you understand this, the more it's going to help. We're going to get to some more of a discussion of complex numbers, some things like that. So understanding these definitions is really helpful. Well, the natural numbers start at 1. They're just, if you were counting on your fingers and toes, you're starting at 1, 2, 3. The whole numbers add 0. Now, integers, I'm always curious why this is like the best definition that we can find, but the integers just add negatives to the whole numbers. So that's the best we can do is we create 0, 1, 2, 3 for the whole numbers. Now we add all the negatives and we've got the integers. Now rational numbers are any number that can be expressed as a fraction. So obviously whole numbers can be as well. You can always put a whole number over 1. Now finally, this is the most interesting and the thing you'll work more with in Algebra 2, college algebra, than you have before, are irrational numbers. These are numbers like pi. They can't be expressed as a fraction. They will repeat, or they won't repeat, and they never end. So like pi is 3.14 or whatever, all those digits. I don't know very many of them. There's another number called Euler's number. Another place you'll see this a lot is roots that don't simplify, like the square root of 11. 11 is a prime number, so you can't find a square root for this. Well, this is also an irrational number. It will go on indefinitely without a fixed pattern. Now, I was always overwhelmed when I was a student with this chart here of how they're interconnected to each other. And so a natural number fits all of the different sets. This is what it's trying to say. Like if we took a look at what a rational number is, got my little chart over here, all of the numbers from the outside in, they're all rational numbers. They can all be expressed as a fraction. The only thing that's outside of this oval here is the irrational numbers. They are a unique thing, and you can't put them into two groups. They're just the irrational numbers. All right, so they're first asking us here to write any of these as a rational number. So can we write these as a fraction? Well, we can. You can just put them all over 1, which makes those rational numbers. So the same here, of course. You could put all of these over the number 1, and now you've expressed them as a fraction. That makes it a rational number. Okay, so here, do you remember, I'm sure you do, if I was trying to do 5/7, this fraction bar is also a division bar. So we could divide 7 into 5 and see if this is ever going to terminate. Is it ever going to stop, or does it ever have a pattern where it just begins to repeat itself over and over again? If it terminates or repeats, then this is a rational number. Now, all of these are expressed as a fraction, so they are, but let's take a look here. So if I did -5/7, if I divided 7 into 5, now I'm not going to do this. If I were doing this in class, it'd be fine to use your calculator. You don't have to do long division. But if I divided these, I get this. Well, I'm assuming by the line they've put here, 714,285, if we divided this again, so if we divided this, it actually all repeats. So you put the line over top of the section that has begun to repeat itself. So this is an interesting one because that entire group must keep repeating itself over and over again. So instead of writing it over and over and over again, you just give the line over top of the repeating part. But because it repeats, the key is that this is a rational number. Again, 15/3, well, if you divided that, that's 3. That's a decimal that ends. It's just 3.0. 25 into 13, that is a decimal. You get 0.52. That is a decimal that terminates, so that's a rational number. Okay, I'm going to go ahead and I'm going to crunch these on my calculator here real quick. Okay, so you divide 68 by 4, you get 4. So it is terminated, so you could think of it like 4.0. Now 8 divided by 13. Yeah, so I was trying to see, my calculator rounds for me, but so it begins to repeat, and my calculator rounds here, but it appears as if it repeats 1, 2, 3, 4, these 6 digits here. So 0.615384. And because it repeats, it's a rational number. And then lastly, we could do, if I can type it in my calculator, we can do 17 divided by 20. We get 0.85. Okay, nothing repeats, but it terminates. So that's a rational number. Okay, now we're going to take a look at these here, and we're going to see which are rational and which are irrational. So they're irrational, they won't repeat, and they won't end. Now, square root of 25, that can be simplified. It is just 5, and therefore it's a rational number. If we do 33 divided by 9, we get 3.6666, keeps repeating. So because the 6 repeats, then we've got a rational number. Now, the square root of 11, it can't be simplified. This is actually the illustration I made at the beginning. If you were to do this square root on your calculator, the decimals would go on forever. And so you'll find that with any root that can't be a root of a prime number, it's going to be irrational. Now 17 over 34, it's a fraction, so it's a rational number. You could simplify that or express it as a decimal. And then lastly, they gave us this guy here. Now this never repeats. It looks very similar quite often, but it never repeats itself, so it does not terminate. Okay, this is more of the same. I'm just going to go ahead and divide them. You can always pause the video if you ever want to try one of the problems on your own and then check with me. But if you don't need to do that or you just want to watch me work, this textbook doesn't have a ton of examples. Their Algebra 1 book is very, very thorough, but this one has a little less. So I try to supplement that with some other homework problems that I'll work for you. But so this repeats here on 0.09. So that terminates, or it repeats, so that's a rational number. You know the square root of 81 is 9, and since it simplifies to a rational number, it's a rational number. Okay, I'm trying to look here. Although it looks very similar, again, it keeps adding a 0 after every round of division. So this never repeats, so this is irrational. And then 91 divided by 13, let's see what we get. Okay, that turns out D is just 7. So that's simplified down, and it could be expressed as a fraction. So that's a rational number. Now, how about the square root of 39? It does not simplify, so that's also irrational. Okay, so now we're doing positive or negative and rational or irrational. So basically the same kind of thing here. So going through here, obviously this is a negative number. It's rational because it could be expressed as a fraction. Now the square root of 5, it's positive, but it's also irrational. That's a prime number under there, so we can't simplify it. So that makes an irrational number. So on your calculator, you'd get a bunch of decimals that never repeated or ended. All right, so negative square root of 289. Well, 289, the square root is 17. So, and the negative's out front, so we're allowed to do that. That just gets us negative 17. Now, negative 6 pi. Because you're multiplying by that pi number, pi is an irrational number. It never repeats, goes on forever. And so that would make it a negative irrational because pi was involved. And then lastly, yeah, this one begins to repeat after the number 4, or up to the number 4. So this repeats, and so therefore it's a rational number. Okay, there's a whole lot of these. 73 would not simplify, so that's going to be a positive irrational number. This is repeating, so I have a negative rational number. 47 divided by 19, it's going to be rational. Yeah, that's an interesting one. When I divide that, I don't see any repeats, but because we could express it as a fraction, then it's got to be a rational number. Now, D, I have a negative, the square root of 5, that part of the number is irrational, so that makes the whole thing irrational. And then I don't see any repeats here, so this is also irrational. Oh, well, unless they're saying it ends. Oh yeah, I guess they're saying it ends because it doesn't have the dot, dot, dot. So they're saying this ends. So if that terminates, it makes it a rational number. All right, now they're just giving us some names for the different sets. So sets are just groups of numbers, and they've listed here the symbol they're giving for each of them. So we're going to classify these into tables. And what you're going to see is some numbers can fall into multiple groups. Now looking quickly, the irrational numbers, the irrational numbers, they're only in the irrational group. That's all they're in. But if you look at, for instance, 6, it can fall into all of the categories. It won't be an irrational, but it's a rational number, it's an integer, it's a whole number, and it's a natural number. So that fits into all those categories. The 2.6 with the repeating, it's not a natural number. It's none of the first three, but it is an integer. -6, you see how it isn't a natural number or a whole number, but it does fit into those two categories. Okay, so we're going to do the same here for these. Okay, so -35 divided by 7 is just -5. So if I were to make a table like this, whoops, no, it won't be, since it's a negative. It will be integers and rational numbers. 0. So 0 is not a natural, but it's a whole, an integer, and a rational. Now the square root of 169 is 13. So this is all of these. Fits into all of those categories. And then lastly, okay, we're repeating here. So because we have the repeat, that makes it a rational number. All right, I think this is the last idea for this warm-up here, and it's an important one. Do you remember, please excuse my dear Aunt Sally? And so what it means is we always have to go in this order. We got to tackle, so if we're tidying up, evaluating an expression, we have to start with any parentheses that we have. This is actually more accurate to say grouping symbols. So anything like an absolute value would be included, brackets would be included. Then we can move on to exponents. Then we'll take a look. Multiplication and division are actually tied. And so we look at those from left to right, and the same with addition and subtraction. They're actually tied as well. And so if we do these out of order, we'll find that we're not evaluating by the acceptable rules. We'll get a different number sometimes. Okay, now these are pretty complicated, but let me see what I got here. Yeah, one at a time. That's good. Okay, so if we take a look at A here, the first thing, please excuse my dear Aunt Sally, we've got to take care of what's inside the parentheses first. So first we're going to clean up the 3 times 2 and the 6 plus 2. It was in a parenthesis, so it had to be first. Next we're going to take a look at exponents. So I had only 1. I got to square that. Now we're looking at, what do we got left? We have some multiplication next. And there's only one of them, but multiplication has to be done next. And finally, please excuse my dear Aunt Sally, we're down to our subtraction. All right, now these are pretty complicated, but if we look through, I do have a grouping symbol. A root is going to act like a grouping symbol. This has to be done first. So 11 minus 2 is going to be the square root of 9. They went ahead and simplified that down to 3. Now we're ready to move on. So we have no more grouping symbols, no parentheses, so next comes exponents. So they did that. Now, yeah, so in order to get to our division here, we're going to treat the top, let me show you this. This division works as if it was a grouping symbol on the top. I have to simplify the top, and then if it was necessary, simplify the bottom there. So this actually works as a grouping symbol, although it's not technically there, because we can't finish the division unless we finish what's on top of there. We're not ready to divide unless we tidy that up. So essentially, it might as well be a parenthesis. So that's a little tricky. So we tidy that up, we get 21. Now we have division and subtraction, so we do our division. Now finally subtraction, we get down to 0. Okay, we've got grouping symbols here twice. We've got an absolute value as a type of grouping symbol. Now clean up inside of there first. So first we're going to clean up inside of there. It has the power, the property that it makes whatever you get inside of an absolute value a positive, but not until you've cleaned up. So first I'm going to clean that up and get -3. And they actually went ahead and did the other grouping symbol at the same time, because they won't impact each other. Okay, so we get down to this. Okay, well this grouping symbol is not finished. The absolute value now takes effect after you've cleaned it up. It becomes a positive 3. And you get 3 times 3 gets you 9. So we're then ready to tackle our multiplication. Okay, now addition and subtraction are tied. We're going to go from left to right. So we did this one first. We get down to 12. Okay, what do we got here? So we're going to need to remember this whole top and this whole bottom are their own kind of grouping symbols. We're going to have to take care of those individually. But so let's look at the top as if it was its own kind of problem. Multiplication would come first. We would do the 6, and then we would do 14 minus 6. Now on the bottom, that exponent is first, so that's 9. Now if you do 5 minus 9 next, you'll be incorrect. You've got to do multiplication first. Please excuse my dear Aunt Sally. So I've got 10 minus 9, I get 1. Now tidy this all up, I get 8. So we get all the way down, so the grouping on the top has been cleaned up, the grouping on the bottom, and now we're just left with a division problem, and then we've got it. Okay, one last one here. We've got a big mess of, this is hard to read, but we have brackets and parentheses all over the place. If you have parentheses and brackets, what it means is you're going to work inside the house first. So all of this is a house. And we're going to work all the way as far in. We're going to clean from the inmost room and clean our way out. So what I mean is the very first thing, if we're going to work inside of here, we've got to take care of this parenthesis, which would be 3. Now we're cleaning in that house, but exponents come next. So that turned us into 16. Now we still have to clean up inside of here. 3 minus 16 is negative 13. Now I recommend you do one step at a time, but if you're pretty good at this grouping symbol is not going to impact anything over here. So they went ahead and multiplied that as 15. Okay, so we got down to this. Yeah, and so they basically removed that grouping symbol when we cleared everything out and made it a parenthesis. But the point is that this now is multiplication. When I have a number in a parenthesis, this is just 7 times 15. We just don't always show that. We'll show it as a... So if I have a number sitting by a parenthesis, it's multiplication. Now, we're going to go left to right now because we have multiple multiplications. We're going to work our way left to right. That first one is 105. Now, they went ahead and did them at the same time. Be careful if you do that, but it's not going to affect anything here, so it's all right. Just remember, in algebra, the 2 owns that negative sign, and the 13 owns that negative sign. So subtraction and negatives in algebra, they don't mean anything. They accomplish the same exact thing. So I'm going to multiply those. I get a 26. Now we just add all those up. We get 132. Okay. This is going to be hard to do. Don't have a lot of space. Let me see. Last one here. I'd really recommend you pause to see if you can get these right on your own. I'm worried about having enough space here to do this. Okay. So this square root, it's a grouping symbol. I have to take care of what's inside of there. And what's inside of there are a couple exponents. So I could do one at a time and be super careful, but I'm going to go left to right in here, but it's not going to impact anything. 25 minus 16. Okay, now I'm going to go ahead and do over here, because I'm limited on space, I've got to do inside of this grouping symbol, and I would get 1. All right, now this grouping symbol is not done. It still needs some work, so I'm going to clean up under there. I'd get 9. Now, it's still not done. I can do the square root of 9 is 3. Now, just because I need some space, I'm going to go ahead and do this exponent next. It won't change anything over here. So if I square 1, it's just 1. So I've got 7 now times 1. Now, multiplication comes next. So 7 times 1 is 7. Add them up and I get 10. Okay, and I'm going to work with this. Now, because it's division, everything on the top is a grouping symbol and everything on the bottom. Until we've cleaned that up, we can't finish this. So on this top, I've got multiplication and subtraction. Well, I'm going to do the multiplication first, and I'm going to go from left to right. Now, because of space here, I know that doing that second multiplication isn't going to mess anything up, so I'm going to go ahead and do it. And because the bottom works as if it's its own group in parentheses, it's not going to impact the top yet. I'm just going to go ahead and subtract that, and I would get 3. Now I have to finish the top. It works like a grouping symbol, so that's 3 over 3. So I've got 1 plus 1 now. I don't divide that. Add them up, I get 2. Okay, now I'm going to work with my grouping symbols. Remember, a square root works like a grouping symbol. So I'm going to do both of these. So I'm working inside of that absolute value first, and I'm going to get it. Absolute value now is now negative 2.5. Now I'm going to work this one for the sake of space here. Add up underneath that square root, and I get square root of 25. Now these are grouping symbols and they're not finished, so I'm going to now take the magical power of absolute values, makes that 2.5, and I'm going to take the square root of 5, which is 5. Now this is multiplication, so I'm going to do that. It gives me 20. Put those together, I get 22.5. Okay, I'm going to hope I can squeeze in D over here. Now I know this is tedious, but it really does matter. If you don't have this down using the quadratic equation, other properties, it's going to mess up all your computations, so it's a big deal. Okay, so I have to work inside of this bracket first. So like I can't do 5 times 3. That would mess everything up. So I'm going to do 3 squared. So this is, I'm going to put a parenthesis so this makes it clear it's multiplication. Okay, now the 7 is the only thing being squared here. If it's subtracting 7. If the negative had been in a parenthesis, I would square negative 7. But here I'm only squaring that 7 because there's no parentheses. So that's going to be 49. Now it isn't really time to work outside of the parentheses yet, the brackets, the grouping symbols. But just for the sake of space and time, I know this isn't going to impact anything, so I'm just going to go ahead and do that. Now I've got some more work to do inside of here. And again, I'm just going to do 81. So 1/3 times 81 is going to be 27. I'm just going to go ahead and do it, even though it's not going to impact the order of these. So I've got 1/2 now. Now I'm going to turn this into a parenthesis. It's the same. Parenthesis or bracket now. There's no need for multiple things inside this house, so I'm just going to treat it like a parenthesis. I would get -4 in there. So clean up inside of there. Now, this is multiplication. I get 25. Okay, one more here. I'm going to work E down here. Okay, now we have a house here. We got to work all the way as the furthest, innermost room. So the first thing is these parentheses. I can't square this until I've cleaned up this parenthesis, so I get -5 squared minus 4. And again, for the sake of space here, I'm going to start working on this just because it's a little out of order, but I know it's not going to impact what's going on in the other location. Okay, still cleaning up inside this house. That's 25 now because I'm going to do the exponent. Now I have 2 negatives in a row. It's like the opposite of -5, or so I have videos on this if you're unsure about why, but so the 2 negatives will make this a positive. Now we really aren't done in here yet, so we've got to do that guy. We're going to subtract him, get 21. Now I'm done with the grouping symbol, so I'm just going to let it go. I get 26. Okay, now those are real fundamental skills, but they're important skills. You really need to understand that, especially the order of operations, to make sure you're computing some of the difficult things that we'll be doing in this course.